I'm Mr. PSRB Shashank, working as Assistant Professor in the Department of CSE at B.V. Raju Institute of Technology, Narsapur. I'm going to deal with recursive function. As we know, what is a function? Function is nothing but a modular, reusable code which we can use at multiple times during a program execution. Coming to recursive function. Recursive function is nothing but a program or a function which is calling itself. Recursion is nothing but reoccurring of a particular task. Reoccurring of a particular task consists of two things normally. There should be base case and second thing is recursive case. Base case is used to take the program to the next level. As we can see, if I am having a program of adding of first 10 numbers, that means if I am not having a base case to stop that particular program, it will go on repeatedly occurring up to n times. Let us see that in a code also. We have second thing is recursive type of case. In recursive case, dividing that program into subparts. If I want to add number of elements from, I'll say from 10 to 1 or 1 to 10, I can see it. This will become your base case. I'll say in the first iteration it should be 10 plus 9. Next iteration this will be the same again, 9 plus 8. This becomes your base case and the next ones will become your recursive type of case. There should be a stopping point. Recursive case, if I am not giving a stopping point at a particular position, it will repeat up to n times. Like which, you can see it using an example. Let us have an example program to check whether a number is a GCD and we can have a factorial also. So, let us see that. Firstly, I can have a function def. I can create a function using keyword def. Firstly, we will see something called as factorial. Second, we will see GCD. If I want to find a factorial of a particular number, let me say it, I want to find a factorial of 5. That means that should be 5 into 4 into 3 into 2 into 1. That means my program should start with 5. If it is going beyond that one, I should make it as stop here, that's it. It should not go beyond 1. That means iteration should be stopped. See, if iteration is not stopped, what happens if iteration is not stopped? I'll say factorial first. Five, I'll have direct one, factorial of 5. Or you can have some n equal to n equal to int of input of, and you can find the factorial. I'll say factorial of n here. Now what happens if I'm giving like this? I'll say I'm passing this particular n to this function. Now I'll have your function definition here. What can be my function definition? I should have like this: 5 into 4 into 3 into 2 into 1. My answer should be 5 into 4 into 3 into 2 into 1. But I'm having in the first iteration n value is 5. That means I should have n minus 1, n minus 2, n minus 3, n minus 4. Up to that particular value becomes stopped. Like which I can have like this. If I am directly having like this, n into n minus 1, n into n minus 1. If I am having n minus 2, n minus 3. If I am writing like this, written n into n minus 1 into n minus 2 into n minus 3 into n minus 4. If I am writing like this, I'll say you can give n value, I'll give 5. You got the value as 120. What is this? I'm giving that in a directive, iterative type of thing, or I'll say I'm giving it in terms of product. If it is 5, you can get it for 5. If it is more than 5, let me say if it is 6, it's nothing but 720. If I am giving it more than extended type of things, 6 into 6 minus 1, 6 minus 2, 6 minus 3, 6 minus 4. If I am giving it as 7, it's nothing but it is going to the next level. 7 into 7 minus 1 into 7 minus 2 into 7 minus 3 into 7 minus 4. It's taking to your next type of level, but this is not your recursive type of thing. This is just giving a value and repeatedly multiplying that particular next values. It's an iteration type of process. You can have a for loop and you can have a while loop and you can do the same process. But if I am having a function, let me say factorial of n minus 1. If I am having a function like this, n into factorial of n minus 1. First n value, if I am giving it as 5, this will be 5. 5 into factorial of 5 minus 1, 4. If I am giving like this, what happens? You can see maximum recursion depth exceeded. Every recursive function in every programming language will have maximum limit of recursion. It is recursively repeating this particular function more than n times. Let me say Python is having 1000 times of maximum limit exception. For this particular one, it is repeatedly executing more than 1000 times. This will give me an error. This is our error. Recursion type of error. That means I am not having a condition to stop our particular execution. This is not stopping. 5 into 4. Factorial of 4. Again 4 into factorial of 3. 3 into factorial of 2. 2 into factorial of 1. 1 into factorial of 0. Again 0 into something. Minus 1. It's going on giving you the particular values. But it's not stopping at a particular position as it is not having any base case. This is just a recursive case. We don't have anything particularly called as base case. So what I'll do, I need to stop at particular point. What it is giving me? 5 into factorial of 5 minus 1, 4. I'll directly write 5 minus 1. 5 into factorial of 5 minus 1. On looking upon factorial of n minus 1, this is function call. This is jumping to this same factorial of n and it is executing all the things whichever that are there in that function. So what I'll do in this next iteration, what it will be? 4 into factorial of 4 minus 1. This will be like this in the next iteration. In the next iteration, it will be again 4 minus 1 is 3. 3 into factorial of 3 minus 1. This will be like this. Again in the next iteration, 2 into factorial of 2 minus 1. Next iteration, 1 into factorial of 1 minus 1. 1 minus 1 is 0. My ideal point should be factorial of 0. That means if I am going to a value of n value as 0, or I can say n value as 1, I can stop that particular execution. So in terms of this, what I'll give, my condition is after this, I'll remove this particular one, if n equal to 0. I can give like this here. Why? Because factorial of 0. I'm calling factorial function with 0 also at end. So if n equal to 0, I'll say return 1. Sir, why you are not giving return 0? Why you are giving return 1? Why? Because 0 factorial is nothing but 1. That's a particular point. If I am giving this as 0, 0 into 1 is 0. Again 1 into 2 is 0. Again 0 into 3 is 0. Everything the answer will be 0. I'll say if n equal to 0, then that should return 1. Else, I'll give an else part here. Return n into factorial of n minus 1. Else return n into factorial of n minus 1. In the first iteration, value of n is 5. Let us think n value is 5. 5 into factorial of 5 minus 1. Again, factorial of 5 minus 1 will lead to this expression again. It will go to this factorial definition and it will execute all the statements whichever that are there in that particular factorial definition. Next is 5 minus 1 is 4. 4 equal to 0. No, condition fails. If the condition fails, it will come to else block. Again, it will print 3 into factorial of 3 minus 1. It will go to the next level. On seeing factorial of 3 minus 1, it's factorial of 2 now. 2 equal to 0? No. Again, it will go to return statement, else statement. 2 into factorial of 2 minus 1. Factorial of 2 minus 1, it's 1. With 1 value, it will go to this particular function definition. Control will jump to that particular function definition. Again, 1 equal to 0. No, condition fails. Again, it will go return to else part. N into factorial of n minus 1. 1 into factorial of 1 minus 1. 1 into factorial of 0. Now, n value is 0 here. 0 equal to 0. Yes, condition is true now. If the condition is true, that should return an answer as 1. So, this function is returning an answer as 1. 1 into 1, 2. 2 is given to this particular function. 1 into 1 is 1. This is given to this particular function. Again, 2 into 1. 2 into 1 is something but 2 that is given to this particular function. That is the return value of that particular function. Now 3 into 2, it's nothing but 6. That is given for factorial of 3 there. For factorial of 5 minus 1, 4. It's nothing but 4 into 6. That's 24. So this is the value you will get. 24 into 5, at the end you will get the answer as 120. The first process will be in the iterative type of process in a recursive manner. It's like this. Second process will be in the reverse process. 1 into factorial of 1 is 1. 2 into 1. 3 into 2. 4 into 6. 24 into 5. Reverse process. After this execution, it will go to the next previous one. First will be top down. Second will be bottom up. This should be the approach of your recursion process. I can have a recursion process in this particular way. So this will give me answer of 1 and 1 into 1. This will jump to this particular 1 and this will return to 1 into 1 is 1 here. And this will return 2. This will return 6 and this will return 24 and totally 24 into 5 is 120. Let us check it. I can give 5, the answer will be 120. This is just a basic one. Let us have one more thing. I'll say GCD. So GCD of two numbers. If I want to find GCD of two numbers, let me take one number is A equal to something called as 62, B equal to something called as 8. If I want to find GCD of 62 and 8, GCD of 62 comma 8. So what could be GCD of 62 comma 8? That's the first point. GCD of 62 comma 8, if I am finding it directly, factors of 62, there are two methods of finding directly. I can find it like this: 2 into 2. First I can have 2 into 4. After that 4 is divided into 2 into 2. I can have like this. Next, this I can have 2 into 31. So the greatest common divisor is nothing but 2 here. So how to find out it? Using a program, using a recursive program. I'll say it. Look at this particular one. I'll say, let me take two values. I'll say a1 is, or I'll say x, second thing is y. So I'll call these two particular values again. This is function call. So first thing what I'll do is, I'll take remainder of both the things. X percentage y. Remainder of x percentage y. If I am finding a particular GCD of two values, now look at this, print of REM. So I'll say two values, one is 62, x equal to 62, y equal to 8. X equal to 62, y equal to 8. 62 comma 8. I am calling a function with 62 comma 8 values. Reminder, 62 percentage 8. Remainder is 6. Now we got an answer here as 6. First thing is, we are finding a remainder of a particular given values. Highest value is 62. Second thing, we are getting with 8. And we need to check if this is highest one only, we need to check in this manner. Now after looking like this, if I am saying something called as y value is nothing but 8, x value is nothing but 62, and we got remainder as something called as 6 here. Remainder is 6, and if the remainder is 0 or if y value is 0, I cannot go beyond your particular given thing. If remainder value is 0, then that's it. We got our GCD. That's the point. So I'll say first thing, remainder equal to 0. If remainder is 0, that is one thing. And if remainder is not 0, that is one thing. Both the things we can have. That means I can have else part here. If remainder is 0, then directly we got something called as GCD. If remainder is not 0, what's the thing next? What's the next value we have to try it? I'll say return. If remainder is not 0, what is the next thing? Return GCD of, I'll say something called as y comma remainder. Why we are using this? We'll try it using a pseudocode. Return y. First thing, let us have x percentage y. X value, we'll take all this. X value is 62. This is 8. So the answer will be 62 percentage 8. Answer is 6. Remainder is nothing but 6. Remainder equal to 0. 6 equal to 0. No, the condition fails here. If the condition fails, the control will go to else block. Return GCD of y comma remainder. Value of y is 8 here. This is little tricky. You can see it easily. GCD of y. Value of y is 8. Comma remainder is nothing but 6. Now our function is calling with two things. One is 8, second thing is 6. Now x value is 8, y value is nothing but 6. Let me write the function with this again. X value is nothing but 8, Y value is nothing but 6. Now 8% 6, the answer is 2. 8% 6, answer is 2. Again 2 equal to 0, no, condition is again failed. It will go to GCD of Y comma REM. Y value again. GCD of Y. Y value is 6 here. Remainder is 2. Again, a function is called here, new function GCD of 6 comma 2. What is GCD of 6 comma 2 again? Look at this. This is 6. This is 2. 6% 2, remainder is 0. 6% 2, remainder is 0. 0 equal to 0. Yes, condition is satisfied here. Return Y. What is value of Y here? Value of Y is 2. That means this GCD of 6 comma 2 is returning an answer to. Whole process will return an answer to. It will not go to else block again. Once a function is returned, that will stop the execution and control will jump to the next statement. So the answer is 2 here. Again this will jump. Answer of 2 is given to GCD of 6 comma 2. Once a function is giving some return value, this is returning a total particular function. It will not repeat it again. So what is returning? It is returning 2. Again this will give and this will return 2 here. Again this will go to this particular statement and this will give a return value of 2. That means this is the process of execution of a particular statement. This is direct a brute force type of approach. Normally recursive function is a divide and conquer approach. But coming to your GCD type, we are dividing it here and this is a brute force type of approach. Directly we are giving a value, in the next iteration it is giving something, in the next iteration it is returning something. If a function is returning something, it will stop the execution there. Now let us try to execute this particular one. So I didn't give a print statement over there. So the answer is 2 here. If you are trying with other things, I'll say 50 and 5. The next things, the answer is 5. If I am trying with other things, 24 and 12. The answer should be 12. Why? Because 12 into 2 is directly 24. I'll say 36, 24. The answer is 12 here. Greatest common divisor of 36 and 24 is 12. So in this way, you can have your own type of values and you can check for GCD. First, finding a remainder. If the remainder is 0, then you have to return your denominator there. And if the remainder is not 0, then that particular remainder, whichever you got, is given as a denominator, and whichever the denominator you are taking is shuffled as the numerator, or as a base value. So this is how you can find GCD of two numbers using recursion. So you have some limitations of recursion also. So first limitation is what? You cannot exceed more than 1000 times. A Python recursive function will not exceed more than 1000 times. And there are some advantages and there are some disadvantages of particular recursive function. The main advantage of recursive function is it makes the code easier to write, more easier to write. And it reduces something called as time complexity. And it performs better in solving problems on tree structures. And there are some disadvantages. First disadvantage is more use of memory. How you can say more use of memory? If I am calling this particular function, I will say it, GCD of x comma y. If I am calling this function, it will execute all the lines even if it is not satisfying that particular condition. It will check this condition. If it is not satisfying, it will come to else block. That means One particular function, if it is called, it will check for all the lines unless you got a return value. That means a function is checking, even if it's not needed, it is checking 1, 2, 3, 4, 5 lines of code every time whenever it is called. Recursion might be slow, difficult to analyze code. There are two things there: easy to code and difficult to analyze code. If I am having errors here, it's not easy. It's just 5 lines of code. If I am having errors over 1,000 lines of code, if I am making it a recursive function, it's not easy to rectify that particular error. So, we are having good sort of advantages and disadvantages of recursion. And this is about your recursion of factorial and GCD functions in using recursive functions in Python programming. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.